Hi class, today we're going to use the quadratic formula to solve quadratic equations. I'm going to go through a couple of examples, and at the end I'm going to derive the quadratic equation. Okay, the general quadratic equation is we have ax squared plus bx plus c is equal to 0. For example, we could have x squared plus 5x plus 6 is equal to 0. Here a is 1, here b is 5, and here c is 3. For this general equation to solve, the quadratic formula is just negative b plus or minus the square root of b squared minus 4ac all over 2a. This is the quadratic formula. Okay, and it solves every single quadratic equation. So let's do a couple of examples. Let's say we have, okay, so let's show an example. We have x squared plus 2x minus 15 is equal to 0. Now to solve this, the first thing you should do is see if you can factor it. And I'm using an example here that does factor, and so we can solve it that way. And I'm going to use the quadratic equation to show that we get the same answers. Then we'll use the quadratic formula to solve ones that we can't factor. But this factors into x. Well, there's 3 times 5 goes here, and the difference is 2, and there's more positive, so x plus 5 times x minus 3 is equal to 0. So we have x plus 5 is equal to 0. If a times b is equal to 0, either a is equal to 0 or b is equal to 0, or x minus 3 is equal to 0. And here we have x is equal to minus 5. There's a solution. And we have x is equal to 3. There's a solution. Now let's use the quadratic equation. Okay, or the quadratic formula. All quadratic equations look like this, plus bx plus c is equal to 0. So in this case, a is equal to 1, b is equal to this guy here, a 2, and c is equal to a minus 15. Now the quadratic formula is just negative b plus or minus the square root of b squared minus 4ac all over 2a. And that's what our values x are equal to. So we can plug those in. We get x is equal to negative b, so minus 2 plus or minus the square root of b squared, or 4, minus 4 times a, which is 1, times c, which is a minus 15. All that over 2a, or 2 times 1. Okay, so x is equal to negative 2 plus or minus the square root of, well, what do we have here? We have 4 times 1 is 4, 4 times 15 is 60, and the negatives become positive. 4 plus 60, or 64, over 2. So that's equal to the square root of 64 is 8. So we have minus 2 plus or minus 8 over 2. Okay, so one answer, x is equal to negative 2 plus 8 over 2, which is equal to 6 over 2, which is equal to 3. And that's one of the answers that we got right here. And the other answer is x is equal to negative 2 minus 8 all over 2. And that's equal to minus 10 over 2, which is minus 5, right? And that's the other answer that we got here. So we see that the quadratic equation works and can even work for a situation that we can factor, though factoring is much quicker. So if you can factor, you first see if you can factor, and if not, you can use a quadratic equation. So let's look at another example. This example is x squared plus 3x minus 11 is equal to 0. Now, if you look at that, you can't factor it. So we're going to use a quadratic formula. A is equal to 1, comma, B is equal to 3, and C is equal to minus 11. So we have negative B plus or minus square root of B squared minus 4AC all over 2A. Alright, so our x values are equal to these. And so we have a negative 3 plus or minus the square root of b squared, or 9, minus 4 times a times c, or minus 11, all over 2 times 1. So x is equal to negative 3 plus or minus the square root of, let's see, that's 44, and 9 is 53, all over 2. So there's our answers. One is x is equal to minus 3 plus the square root of 53 over 2. And another answer is x is equal to minus 3 minus square root of 53 over 2. And you can plug that into your calculator and get values. But it's often written like this, and let me just write it a little bit clearer. Negative 3 plus or minus the square root of 53 all over 2. Now you can write it like this, and that's understood to be these two answers because of the plus or minus, and that really gives us two answers. Okay, we can't factor that, and that's why we're getting a square root that doesn't simplify to a nice integer. Alrighty, let's try another example. We'll do a different one. 4x squared, where this a term is not equal to 1, minus 3x plus 6 is equal to 0. Alright, so a is equal to 4, b is equal to minus 3, and c is equal to 6. So negative b plus or minus the square root of b squared minus 4ac all over 2a is equal to, we have a negative 3, so it's a positive 3, plus or minus square root of b squared, which is 9, minus 4 times a, minus 4 times 4 times c, 6, all over 2a, which is 2 times 4, or 8. Okay, so our x values are equal to this stuff. Alright, so x is equal to 3 plus or minus, well, what do we have here? We have 9 minus 4 times 4 times 6, so, okay, we have the square root of 9 minus 96. Okay, all over 8. Now this is where we get into a second type of answer. We have 3 plus or minus the square root of a negative 87, right? All over 8. Well, you can't take a square root of 87, not in real, but we can have imaginary numbers where I squared is equal to a minus 1, right? So we can factor that out. We have an I. So we get x is equal to 3 plus or minus I times the square root of 87 all over 8. And actually it's more typically written as 3 plus or minus the square root of 87i. I is on the outside of that square root, all over 8. Okay, so it's really 3 types. If this b squared, I'm going to go to a new page here. There's really 3 types we have of solutions. We have, and it's called the discriminant. Right? We have negative b plus or minus the square root of b squared minus 4ac all over 2a. Right? It all depends on this b squared minus 4ac. Right? So if b squared minus 4ac is greater than 0, then we have a square root of a positive number and we get 2 real solutions. Okay. If b squared minus 4ac is equal to 0, then we get 1 real solution. Okay, because that's just 0 then, so we just have negative b over 2a as the solution. And then we can also have b squared minus 4ac is less than 0, as we saw in our last example. And then we have a square root of a negative number, so we use I, so we have 2 imaginary solutions. Okay, so let's see that in action. Okay, so let's see if we have x squared plus 8x plus 3, all right? So what is b squared minus 4ac is going to be equal to, b is 8, so 64, minus 4 times 4a, which is 1, times c, which is 3, and that's 64 minus 12, that's greater than 0, so we have 2 real solutions. Okay, now say we have 9x squared minus 12x plus 4, well, no, is it to be equal to 0, then b squared minus 4ac is going to be equal to, well, we have b is equal to 12, or negative 12, but squared is 144, minus 4 times a, which is 9, times c, which is 4. Okay. And 16 times 9 is 144 as well, and that's equal to 0. So we only have one real solution. And let's get the solution. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a is just going to be equal to, well, b squared minus 4ac is 0, so that's 0. It's just going to be equal to a minus b over 2a, which is equal to a positive 12, negative minus a negative 12 is 12 over 2 times a. A is 9, so that's 18. So then we have one real answer, which is 2/3. Okay, just to solve that one, give you an example. We had one real solution. So one real solution. And if we go back 2 slides to this one here, if we look at our discriminant, okay, on that one, that was 4x squared minus 3x plus 6 was equal to 0. So this is example A, B, and C. Okay, then b squared minus 4ac was equal to b squared is 9. Negative times negative is positive. Minus 4 times a, which is 4, times c, which is 6. And that's clearly 9 minus a pretty big number. That's clearly less than 0. So we get 2 imaginary solutions, as we saw. Okay, so there we go. Okay, now we can derive the quadratic equation. If we have ax squared plus bx plus c is equal to 0, what we need to do is complete the square. The way we do that is we divide both sides by a. So I get x squared plus b over ax plus c over a is equal to 0 over a, which is just 0. Now how do we complete the square? We take half of this, so we take b over 2a, and we square that. Remember from completing the square. So that's b squared over 4a squared to complete the square. So we have to get that on this side. So we'll first subtract the c over a. So we get x squared plus b over a x is equal to a minus c over a. Okay, now we add b squared over 4a squared and b squared over 4a squared to both sides, right? Now this is a perfect square. This is x plus b over 2a squared is equal to, well, let's just get a common denominator, multiply top and bottom by over 4a, so 4a and 4a. So if we combine those, we get b squared minus this one, 4ac, and that's all over 4a squared. And you just get a common denominator there and put the negative there. Now we take the square root function and the square root property. So a plus b over 2a is equal to the square root of this, really plus or minus the square root of b squared minus 4ac all over 4a squared. And now you can see it. I'm going to then add, subtract the b over 2a over here. And we get x is equal to a negative b over 2a plus or minus well, the square root of 4a squared is just 2a. And we have on top here b squared minus 4ac. And we have a common denominator, so we can combine those. Negative b plus or minus the square root of b squared minus 4ac all over 2a. And there's a quadratic formula derived from a general quadratic equation right here. Okay, well, I hope you enjoyed this video and it was helpful to your learning. Cheers.